Hi, I'm Nicky Fox, and I'm in charge of all sun science here at NASA. This is Ask NASA, and I'm here to answer your questions. Is the sun a ball of I have a model of the Parker Solar Probe spacecraft here. Could I get some sun in here, please? So the important thing is, as the spacecraft moves around the sun, the heat shield has to remain pointed towards the sun at all times. So the heat shield, the front of the heat shield, will get to about 2,500 degrees Fahrenheit, but the main body of the spacecraft is nice and cool at about 80 degrees Fahrenheit, which is a bit like a balmy Florida evening in August, I guess. And that's Parker Solar Probe. Thank you. Good.
Look how polite you are.
So one of the things that we discovered with Parker Solar Probe on the very first orbit was switchbacks. Switchbacks. If only I had a model of the corona. Ah, thank you. So switchbacks are really reversals in the material coming from the sun. So the sun has a magnetic field, and that is continually moving away, or so we thought, continually moving away from the sun. But what we found with Parker Solar Probe is this magnetic field actually kind of reverses on itself and makes an S shape, and we call that a switchback. It's hard to twist a magnetic field. It's like trying to twist a rubber hose. It's hard. And so somehow there's this energy going into the magnetic field that's causing this S shape, and when it releases, it's letting all of this excess energy out into the solar wind. Thank you. Studying the sun is really important as we get ready to support the Artemis mission. We're really protected here on the planet by our magnetic field and all of that atmosphere around us. Our astronauts, when they will be on the moon, and of course as we journey further to Mars and beyond, we'll be traveling through the solar wind and living really more in the atmosphere of the sun. And so it's key as we go forward to the moon, to Mars and beyond with our Artemis mission, that we really understand the source of energy in the heart of our solar system. Parker Solar Probe, on her final closest approach after she's done all of those Venus flybys, she will be at about 3.9 million miles above the sun's surface. We have many materials on Parker Solar Probe that don't melt despite how close they are to the sun. In fact, that was one of the big technology challenges for us, to find materials not only that don't melt, but can actually withstand the incredible change in temperature, because Parker goes very close to the sun and then comes out around the orbit of Venus, which means that all these materials go really hot and then really cold at least 24 times. So the critical thing for Parker Solar Probe, of course, is to keep that heat shield pointing at the sun. At some point, she will run out of fuel. At that point, unfortunately, she will start to turn, and the full illumination of the sun will hit parts of the spacecraft that are not designed to see the sun. And so she'll break up into large pieces, and then they will get gradually smaller and smaller until they become really tiny. And so I like to think that she will become part of the corona, and she will orbit the sun forever. So honestly, we don't know what new science we're going to expect. We've already seen unbelievable stuff on our first couple of orbits. Science is a voyage of discovery, and that is what Parker Solar Probe is doing. She is going into a region where we've never been before. And so honestly, we expect the unexpected. My favorite aspect about the sun is it's a star, and it's a star that we can go and visit. And so you think, you look up in the night sky, you see all of those stars, and yet we're actually sending a spacecraft right into the atmosphere of a star right now. And that means we're going to understand more about other stars in our universe, and that's amazing.
Do you have a question for NASA? Send your questions to our experts on Twitter using #AskNASA.